Welcome to Nautobot Workshop. This series walks through building a fully automated network lab using Nautobot, Containerlab, and Docker. If you're looking to integrate a source of truth and automation into your workflow, you're in the right place.
Hey, welcome back to Nautobot Workshop. This is part 3. We're going to talk about managing Nautobot with Ansible. To get this set up, we're going to create a new virtual environment using Python 3's venv. You can see up on the screen there, we did a sudo app install on the Ubuntu VM that I'm using. That installed our Python 3 requirements to set up a virtual environment, as you can see there under the dependencies. After that, we use the Python 3-m venv.ansible, and the .ansible is the folder where you're going to place your virtual environment. So under our new folder called Ansible-lab, we have now a folder called .ansible, and this is where we'll manage all of our dependencies for using Ansible essentially. So after you have the virtual environment set up, we'll go into that virtual environment with the source folder bin activate command, and that will place us into the virtual environment. Now, some of the benefits here of a virtual environment is you can manage your Python dependencies per project. It's much easier to switch between projects where you're not installing your Python modules on your OS level Python, right? So this abstracts it away. You can contain it to a folder or a project, or maybe a folder with lots of different projects that you don't have to worry about different sort of dependencies on different versions of modules conflicting and stuff like that. So separating this out, I tend to do it per Ansible playbook, or Ansible project, I should say. So this is kind of how I do it. Poetry is another way to manage that stuff as well, the way we did with the Nautobot Docker Compose folder and getting the Nautobot Docker set up. You can use Poetry as well to manage dependencies per project. So anyway, once you've activated your virtual environment, your Python virtual environment, you want to do pip3 install for Ansible, pynautobot, and then we'll just do netadder. And this way we'll have the main things that we need. Ansible, of course, we'll need so that we can run Ansible playbooks. Pynautobot is the Python module that interacts with Nautobot from a Python level. The Ansible Galaxy collection for Nautobot uses that as well. And you can learn more about that. Just look it up on pip, or PyPy, rather. So once we have Ansible installed, which looks like that has finished, pynautobot, netadder, we'll need to do one more thing, and that is to get our Galaxy collection installed from Ansible. Before we do that, one thing that I typically do in all of my Ansible projects is I create an Ansible config file. And the way Ansible works is it will look for this config file in the project folder first, and then default to a global one that's installed with Ansible. So you can manage how your Ansible functions per project as well, just by including this config file. And I kind of do the same config file in every project. So kind of, paste this in here. Let's just go over this quickly. I like to put my inventory in the inventory folder, so I set the defaults for that here. The host key checking, I just make false. That way, if I've never connected via SSH to a switch or a router, it ignores that click yes or no, or type yes or no thing that you get from Linux. And then we auto add that to the host key we auto add. So you can set all that stuff here as a default, and then you won't get errors when you run your playbooks. There's a few other settings in here that I've had for a long time that I keep. my standard callbacks. So whenever you get some kind of debug output at the CLI, it'll put it in YAML format, that kind of stuff. Timeout, this is just kind of standard stuff. And then the Python interpreter, this you probably want to change. It won't matter too much. This is going to be more for where it's going to look for Python on the host you're connecting to. And since we're really just managing other switches and routers, won't really use the Python interpreter because there isn't a Python interpreter on the host we are connecting to. So I think typically you could probably even take this out. It will default to whatever the OS is. May or may not need that, but anyway, so I think we'll just comment that out. So I kind of forget why I had that in there, but that was for a reason, I'm sure. Collection path, that's the next main thing that I like to set. And what this will do is it'll actually, anytime we install any Ansible collections, it'll actually stick it in the project folder. So if we shrink that up and we go ahead and do the install, we'll see a new folder called Ansible collection show up. Ansible, the way it's set up is it will check this folder first in your project folder, and then of course default to the standard installation location as well, which I believe would be under your virtual environment folder if you just let it go to default inside of your, I think it's the lib64. Yeah, here's Ansible collections there. So it would typically be kept here. So when we do a pip install, that's where put everything. So all of the standard libraries and modules and collections that come with Ansible are here. So anyway, I just like putting it in the project folder. You don't have to do that. It's just easier for me to figure out what I got installed for the project, having it there. All right, the last thing is the Vault password file. So I've placed this here, and I'm not even sure if this is in the right spot, but anyway, I've placed this here because I'm going to use Vault to manage passwords and secrets and stuff. And this will be in a text file in the root directory of the user I'm logged in as on this VM. So that's where that will be. And we'll kind of go through that when we need to get to it. We're not going to need it right away. All right. So we got our config file. Let's close this up so it's less confusing. We got our config file here. And let's install the Nautobot Ansible collection. So we'll do Ansible Galaxy collection. I think it's collections. Collection. I think it's collection. I think we do install network to code dot Nautobot. Okay, so you can see our Ansible collections folder was automatically created there. And it's going out and getting the latest version of Nautobot network. Network to code's Nautobot Ansible modules. Okay, so pop this open. We can see here version info, and then of course all of the components of the module. If you go under plugins and modules, these are the actual modules we'll make use of. And what's nice is with Ansible, if you click on one of these, let's just click the device.py, you will have documentation in there, which tells you all of the fields that are available. Okay, and what it takes as input. So like status takes a description, and if it's required or not, it'll tell you here. If it's a dictionary, it'll tell you there, all that kind of stuff. And then under examples, they actually give you like here's a quick task and how to set it up, what it should look like. And from a YAML standpoint, the indentation scheme you should have. Okay, so that's helpful. The other reason I like to keep it there is I can find it very quickly. If I need an example of how am I supposed to set up this task for the module, then I just go check there, or even just copy paste it in, right? Okay, so now that we've got this set up, And we have our config file. We've got this module installed. I'm just kind of reviewing my notes, so I'm looking over here. I think what we'll do first is let's create a couple of things that we do need. So if we do a touch over here for the group vars, because there will be some stuff that we'll keep in there. So let's do that. I can't touch it. Do I actually have to make that directory first? I didn't think I did. Oh, you know what? Let's see. Let's try this again. Touch, inventory. What am I doing wrong? I don't think I want to put a slash here. No. Cannot touch. Oh well. Alright, so why don't we, if you're using VS Code, you can just come over here. We can create a new file, and we're going to call this inventory. So we can put, when we create files, you can actually put folders in the file, and it'll create it with that folder structure. So let's create our inventory folder and our group vars YAML file. So what we're going to do here is basically under the all YAML with Ansible, this variable will be included with every and any playbook task that we want to run. Always available. So what doesn't matter what's in your inventory file, this will always be available as a variable to use. Inside the YAML, you can do this one of two ways. We talked about using Ansible Vault. So in here, we can put our localhost 8080 for the NB URL. And then for the token, we actually just place the token here in plain text. The other option would be to use Ansible Vault to get the same information. And then you don't have to have your secrets in plain text here. What you could do is then just reference that as a variable. So what we could do in here is do, we'll say, I don't know, we could do capitals, right? Nautobot token, like this. And then that will be referenced as the variable, and it will look at Vault to grab that. The other thing you could do is maybe do Vault. That way you know it's a Vault token or a Vault variable. Okay, so now what will happen when we run a playbook and we use this variable in our task, it will look this up out of your Vault file. Okay, so let's just plan on doing that for now. Next piece that we'll want to do is start getting our roles set up. So there's a couple ways you can build Ansible playbooks. You can just put all your tasks in the playbook, or you can reference a role, which is a folder that you're going to create in here. So we'll create a folder called role. And then what we can do is we can actually divide up our different groups of tasks based on like a folder structure here. It's a little more organized. So like if we created a load Nautobot folder, for example, we can keep our Nautobot loading tasks in the load Nautobot folder. Create another folder called tasks, and this is where the tasks would go. You always have a main.yaml. That's the default that it will look at first. So anything in here, default YAML, or I'm sorry, in the main YAML will be the task that is looked at in order from top to bottom when you reference this role in your playbook. So let's talk about what to do first. I think what we want to do first from this load Nautobot roles thing here is talk about like organizational stuff from a task standpoint. So at this point, we're going to have, I think, at least 5 different tasks. That's sets of tasks to load Nautobot. And those sets of tasks are going to include quite a few tasks in them, right? So we'll want to break those up, I think, into different files. What we want to start with is the extensibility piece in Nautobot. And so you're probably wondering what I'm talking about. So why don't we switch to the Nautobot application, and then we can figure out. All right, just save that. All right, so we have our Nautobot application that we installed in part 1 running in Docker. We don't have anything loaded in here yet. This is a fresh install. Extensibility. So over here on the left-hand side, again in Nautobot, we have the navigation menu essentially. And under extensibility, we have the ability to create custom fields down here in the data model section. What we can use these custom fields, there's also computed fields too, but for what we'll use is a custom field. What we can actually create with these custom fields is we can assign new fields to different sections of Nautobot. So for example, if we wanted to have a custom field under the interface tables, we could create a custom field there. Or maybe in the device. And so what you can do is you can actually use these custom fields for additional organization. You can use it for tracking maybe what interface is part of OSPF or ISIS, something like that. And that's kind of what we'll use it for, is a way to track those specifics, right? We want to know what interface is under OSPF. We want to know what kind of interface this should be, whether it's a point-to-point or a point-to-multi-point, stuff like that. And so what's nice is we can manage all of this from the GUI, which is great, because you go in here, if you need to add something really quick, you can just click this plus button and you have a bunch of options. You can group them by specific groupings. So like in our case, maybe we want to use OSPF as a grouping. The other thing too is you can provide this key. So this would be the name. You can see I have stuff filled out here, right? So OSPF_network would be the name of the field. And so when we reference it, anytime we're loading data in it or extracting data out, it's going to be under that key. And then what we can choose here is the type of data that's being inputted. That doesn't sound right. The type of data you're going to input into the field. Right, so we could do text, integer, Boolean, true, false, which is kind of nice. And we can do selection or multi-selection. So you could set something up that maybe there's multiple things that an interface should be tracked under. And so what we could do is we can actually create this multi-selection thing where you have a drop down and you can select more than one selection from the drop down. You can do JSON and you can do Markdown. So there's a lot of cool stuff in here that you could use any way you want. But what we'll do is we'll sort of use, I think we'll use basically integer and maybe selection for our needs. This just avoids, like with text, the thing that stinks with text is people could enter anything they want. But Nautobot thought of this, right? People at Network to Code thought about this. What they provide are validation rules. So you can actually create a regex to validate what's being typed into a text field. So if you wanted to, say, use a text field to track whether it's a point-to-point interface, and that's all you wanted to go in there, well, then you can do a validation regex in there so that only what's accepted in that field is exactly typed in correctly based on the regex rule that you've provided. With integers, you can provide a min and a max value as well. So if you only want, let's say for OSPF areas, maybe 0 through, I think it's 65 something thousand, I forget the exact number, but you could limit then the value that gets inputted in there as well. And I think OSPF version 3 would be higher, I believe. This assignment section here in the middle, this is the table you will assign this custom field to. So you can choose any of them. In our case, we would want, under DSIM, we'd want interface. So you have a couple options here, interface templates or interface. So what we would do is we would assign it here to interface. And anytime you were editing an interface, this custom field would be presented to you in the options that you can choose to edit or change. Okay. So this is extensibility. There's a lot of other things under extensibility, but I just wanted to cover this piece so we can understand what we're doing from the Ansible side and why we're adding things. So what we're going to do is we're going to save this in our main YAML. Again, this is the main YAML is going to be the thing that Ansible looks at first when loading this role in our playbook. We are going to create another file called extensibility.yaml, and this is again under the tasks folder. And so what we can do actually from the main task is we can reference other tasks, and we can even add tags so that, let's say we wanted to just update extensibility after we've run this whole thing, like, oh crap, we forgot to add something, now we want to add it back in. Well, we can change our data that we're using to load this, and then we can use the tag to actually just run this set of tasks rather than the whole entire playbook. So that's what tags are good for. You can kind of break up where things run, and then you don't have to go through the entire playbook over again from scratch. In our extensibility YAML, we're going to create custom fields. So if you look at the Ansible collection folder here, we go down to plugins, like we talked about earlier under modules. There is going to be a custom field. I think it's custom field. Yeah, I think it's, so we're looking for C, custom field. Yep, here it is, custom field. So we can add a custom field from Ansible into Nautobot. What's great about this is we can just create what we need in a YAML file, load it, and then just stick it in here. So down here at the bottom, and these are, again, like we talked about earlier, these are the different fields that are available in this module. Okay, so when we were looking at all of the options we had with custom field, you should be presented with those options as options here in the module. So here is create custom field inside Nautobot with all the information. I typically just take these and just remove what I don't want. Right, so we have our weight, the type, a description. There's this filter logic here. Advanced UI, what does this do? Well, Advanced UI will actually put these custom fields under an advanced tab. So you can, if you don't want it there and you want it in your standard, from the GUI standpoint in the standard interface fields, then you would make that false. The content type. So here's the thing with the tables or content types, as they're referred to in Nautobot, is you need to get these right. So for instance, dsim.device would reference the dsim module and the device table. So if we wanted to get interfaces, then we would use dsim module with interface tables. And so that would be dsim.device. Some of the content types have spaces in them when you're looking at them from the GUI standpoint. And so there are no spaces and everything's lowercase from an Ansible standpoint. And so what they typically do is take the spaces between dsim, or it might be a pipe, they take that pipe and replace it with a period. They typically take spaces and remove them or add underscores. So you'll have to do some research and kind of maybe you can use the API to look at those and find those. I believe there is an API that will give you all of the content types, and then you can pull those from there, or you just use a whole bunch and you sort of start memorizing them, which I'm getting close to. But anyway, so what we want to do in our extensibility is we're going to basically use a version of this. Why don't we just take this whole thing, copy it in here. I typically put the thing at the top for YAML. And then basically we'll leave the name the way it is. Doesn't have to change. What we can change, however, is this section here. So since we're using our container, we're going to set all of our validate certs to false because we're not going to have a valid cert. So what needs to be referenced here? So when we talked about setting up this all folder, we're going to reference the MB URL. And since we're running this locally, we'll use localhost. If you were maybe running the Docker container on your computer, well, you'd still use localhost. But if you were running it, say, on a different VM or something like that, then you'd want to put the IP address or whatever URL you registered internally from your home lab or whatever. And then, of course, the NB token. We need to match this variable as well in Arc in here. So these match our variables in the all, which will be available when we run this playbook. Okay. Now, before we make changes to this, let's talk about getting the data set up. So over here, let's close this down. We want to create a new folder under here. We'll call it Nautobot data. This is going to be the data we're going to use in our playbooks to populate the source of truth, the Nautobot source of truth. Let's create a new file and we'll call it extensible data.yaml. And so in here, under our extensible, actually, yeah, I think that's what we want to call extensible data. There we go. We're going to create kind of a structure, right? So of the custom fields we want to generate, we talked about we wanted OSPF network type. So we'll give this a name. Now you can include spaces in your name or not. You'll basically reference those by the name whenever you're actually by the key, sorry. So the name, this is how it will appear as a name field in the GUI, and then the key is what you'll end up using later on. We're going to do a type of select, and we're going to say choices. We'll have point-to-point, broadcast, non-broadcast, and point-to-multipoint. And then we'll assign this to the dsim.interface content type. All right, so what I'm going to do is I'm going to split this screen so we can see. And we want to lay out our task to match up with this. So under label, we want to change this to a variable. So I'm going to do item dot name for the label. Okay. The group, change that to a variable referencing the group over here. And we'll say item.grouping. That should match up with the key value pair over on the right hand side there in our data. Just gonna go down and do all these the same way, right? So there's key for type, the type, change this to type, okay. Weight, just leave it at 100. I think the weight is going to be, and I gotta check this, but I believe this is how it's listed or sorted in the Nautobot GUI. So I think a larger weight will be at the top, a lower weight would be towards the bottom. So you can weight it by importance or something like that. Description, required. So required, what is this? So this, if we edit the interface, and this is required, then you have to fill something in here. So we want to make this false because we don't want to necessarily have that be required for every interface because we have interfaces that won't be in OSPF. Default, we'll keep this field, but what we'll do is if we don't have it defined, we'll actually change this to omit. Now what'll happen here is if we don't have a default in our key value pairs in our little dictionary over here on the right, then we'll just omit this field from being entered at all, okay? Filter logic we'll keep as loose. Advanced UI, again, I think we'll make all of these false because I want them to show up in the GUI under the content type that we've assigned it to. All right. This stuff here, we're going to do the same as we did above. Oops, let's get these in quotes. So we're going to say item validation minimum default omit. We'll do the same thing here, right? And validation regex, same thing there. That way we have all the fields if we need them. If we change our mind and we want to put something over here, then all we have to do is just add the key value pair to match up over here. All right, content type is one thing we need to fix. So you can see this is a dictionary, or sorry, I guess that would be a list, wouldn't it? The way we do lists in here is you copy a list. So if you noticed under, kind of lost my train of thought here. Content type, where is that? I think what we'll do here, oh, sorry. Okay, so let me just start over. So you'll notice over on the right hand side with content type, it's a list. You'll notice under my dictionary, I have it, as the extensible data, I have it as a list as well. And so the way we can reference that in Ansible is we can just put the whole list in as a key value variable, right? So if we just reference this as content type, we don't even have to do join. Get that out of there. I don't like that suggestion. We can just basically take this entire, so if I had more than one choice here, which you could do, we just need to take this key value and stick it in here, and it will take everything under content types as a list, and we'll insert it in here in your playbook. Right, so that's an easy way to get lists into playbooks like this without having to do some crazy join or crap like that over here in your task. All right, state is present. So what present will do is it will validate if it exists before making any changes. So nothing here will change if you run the playbook again, unless there's some value that has changed. Does that make sense? So the next piece we want to add is a loop, and we'll just say loop custom fields. Okay. The next piece that we'll want to do while we're here is the custom field choices. So if you go back under your modules, you'll see there is a custom field choice, and we can add this. You can basically take that as a default, the example, and just make the changes like we did above here. We'll want to do value, custom field choice. We had a few items that had choices. So the one we're looking at right now is one of those actually. So we'll want to input this value as we'll call it item.1. And the reason why we're doing that is we're going to loop over the custom field choices under custom field. So the way we'll do that is with a sub elements modifier on the loop. So we'll do something like this, and we'll do sub elements on choices, and then I always add this in. Skip missing equals true. Okay, so what's going to happen here is we have basically a list within a list. So under the custom field list on the OSPF network type, we have a list of choices. And what this will allow us to do is to get into the secondary list under the parent list. Or I guess we'll call it a child list. I guess that's a good name for it. So allows us to get into the child list, the sub elements does, to the child list of the parent list. Parent list is custom fields, the child list is choices. And so the way you reference this is without any loop var changes, right? It's always item is the default here under Ansible. We can just do item. Period 0 would be the parent list. Period 1 would be the child list. And so we can reference that by item period 1, which is choices already. So we don't have to type anything after this. We can just reference this as item period 1. We'll want to wait, and we'll just keep this at 100. We'll want custom field key. Actually, that's wrong. I want custom field. So what we're doing here is to add the selection, we need to pick the custom field it needs to be a part of. And because we have to create the custom field first before we can add a selection, that's why we're doing this as a secondary task and not in the main task that creates the custom field in the first place. And then we want to do state present. Okay. So there's our first task to add the extensibility data into Nautobot. Now what I'm going to do is I've already had this built, and I have a GitHub repository that's called Nautobot Workshop under my GitHub, and you can get all that information there. But I'm just going to paste this in, and I just want to provide an example structure that you could use for any other task you want, really. So what we're going to create is a network, OSPF network type, area to the interface. We want to assign cost to the interface, potentially authentication type to the interface. This will be a choice. And you'll notice this will be an integer. Next up, hello intervals. If we want to fiddle around with those, we'll assign those to the interface as well, because the reason why I'm assigning it to the interface is typically, especially with Cisco, and I believe Arista is going to be very similar, you're going to make those changes for these items at the interface level of the configuration. And so that's why I'm including it here under the interface for a lot of this stuff. The dead timer interval, the BFD enabled, all that's going to be done at the interface level, I believe. I'll have to check on that BFD, but I believe on iOS that's where it would be done. MPLS as well. We'll enable that. You enable that globally, and then you'll enable it per interface. So we'll want to track that as well under Nautobot as their source of truth. Okay, great. So we have this data. Next thing we want to do is we're going to create another file called build lab. Real simple, right? So I typically name my playbooks with a prefix of PB for playbook. And I use the short form of YAML. Whoops. So PB build lab YAML. Create a new file here. We just drag this over to this side. Under here is where we're going to create our actual playbook. So in the playbook, we're going to give it a name. This is going to just use localhost, local connection, and we're not going to gather any facts. Then what we want to do here is we want to include files that we're creating here. So for example, we just created this extensibility file that carries all of our extensibility information that we want to add. And so we'll load that file at the start of the playbook. Then from here, we want to reference the roles we want to use. And so this will look like is role. We'll grab the name of the folder. That's it. So we can create a list of folders here that reference the folders we're creating under the role folder in our project. And when we run this, it'll reference this folder. Close this real quick. This main task YAML first, which has the import task of extensibility here. And we can run this with or without a tag at this point. It's the only task we have, which will reference this task file, which references these tasks in the task file. And that's kind of the structure. We'll pretty much do a lot of the same thing in this section of the post. And again, this is on my GitHub. So GitHub burn-baker under the Nautobot Workshop repository. You can find all of this information. So it's easy to look up. All right, so let's test this out and see if it actually works. We got this playbook. Oh, one thing we need to add, the vault. So why don't we just go over the vault? We want to create a vault text file. We're going to do Ansible vault vault.yaml. And I think I have to add a password. Oh, vault create. Okay, we're gonna add a password to this. We'll just call it vault1234. Vault1234. That's a super secret password. Let's try this again. I hit the wrong keys. Okay, our super secret password is vault1234. This will show up as a VI, basically type editing. The thing that we do want to add to this file right now, and we'll add more to it as we go, but over here we talked about in our all, we wanted to reference this Nautobot token. And so in here, we're going to hit I to do an insert. We're going to just paste this in here. I believe you're going to set this up like a YAML file, right? So this is a key value pair. So we'll do the colon, and then in quotes, we're going to stick our token. And the token, again, we created this, I believe, in the first video, but from an Ansible standpoint, what you'll do is you'll go back to your Ansible GUI, and under admin at the very bottom, the file that you logged in with, you're going to click profile, and under profile, there's an API tokens section there, and you'll just copy that token that you created in that first video if you're following along. And then, so we can basically go in there and just copy that out. And let's jump back over here, and we're going to paste this in. So that's my super secret token. We're going to keep it in Vault so we don't have to put it in any of our playbooks that maybe we want to store on GitLab or GitHub or whatever. Okay, so we'll hit escape to get us out of insert. We'll do WQ for write quit. And now we have a Vault file. Now, let me just show you something fun here. Shrink this down. So if we click on Vault, now it's encrypted. So you can't see it. Nobody else can either unless they know the password. Okay. And so what we'll do now when we run this playbook, we're actually going to reference that Vault file like this. We can say Ansible playbook eb.build. I think, is that what? Yeah, it's build lab. Build lab YAML. You can say vault password this. Now, one thing we can do actually with the vault password is we can reference a file to keep it in there, so I don't have to type it all the time. And you'll notice, or you'll remember in our Ansible config file, we had this thing here. So what we can actually do is we can actually create this as a hidden file over here. And we type in our super secret 1234 password like this. Now, when we do vault password, we can actually reference it. See, like this. And then we talked about tags. So the way you work with tags is in the Ansible playbook command, you'll do this reference of a tag. And then what you can do here is you can actually reference tags with comma separated list, right? So if we want to do extensibility, then devices, blah, 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 we would just do it with a comma separating each one. And so our tag in here, if you recall, was extensibility. So we'll just reference that. We don't need to do it since we only have this one task. We'll go ahead and do it just for fun. Okay, let's just double check our thing here. So we're referencing localhost 8080, which is running locally on this version, on this VM. So let's see if it works. Okay, yeah, we needed to fix really quickly the, we're missing HTTP, right? Kind of need that in the URL. Makes a big difference in everything working. So a lot of little things we left out. I've got it added back in there. Let's try this again. to take my headphones off. Forgot I had those on. We're getting uncomfortable. All right, so let's run this task now that we've got all the little stupid things figured out. Hey, we're adding stuff. Fantastic. We can see things are changing. Looks like we failed on the custom field choice for some reason. Let's take a look at this message. Could not find choices. Ah, you know what? Yeah, silly me. Okay, so here's the problem. Every single one of our looped items don't have choices defined. So it hits this one. Yeah, that's got it. This one doesn't, so it fails. And it looks like that's the one it may be failing on, is that second one. So it won't even make a change on any of them because it's noticing that our data is not matching all the way through. So the way we handle this in Ansible is we use a when statement. It's sort of like an evaluation of like if something exists or doesn't exist, then we run the playbook or not. Let's do that. So I think what we want to do here is add this when statement. We want to say item 0 choices is defined. Okay. So there we go. So now that we have this evaluation added to here, it's going to basically skip these guys without choices as a key defined in the data. So let's run this again. One thing you'll notice is this green. So there's no changes being made because we've already added those custom fields. And so the module is validating that we're not adding those in green. Now, why did we fail again? The reason why this was failing is we want to make sure when we're defining a sub element in the loop, you actually define it correctly. So I had screwed up how I was using the skip missing true in here. When we're iterating over that sub element of choices. So what we want to do now, got this saved. Let's see if this works correctly at this point. Oh my gosh. What am I doing wrong? All right, so we have something wrong. Use parameter for network to code, custom choice, module weight. Supported parameters include API versions. Okay, so weight is not supported. Well, spelling weight incorrectly is not supported. All right, jeez. Terrible typer. I apologize. All right, let's try this again. I think it'll work. I think it'll work this time. Okay, there you go. Spell things right, put things in the right order, do them correctly, and it works. There we go. Okay. So let's switch over to the Nautobot application. We'll take a look and see what we added. Okay, so looking at the Nautobot application, there's my API token. So let's go back down to extensibility over here on the left. Let's click custom fields. Okay, so here are the custom fields we just added with an Ansible playbook. So we have everything we wanted in here. None of these are required. They have the correct weight. If we click on one of these with choices, we should also have choices defined. I think it shows up in here. Oh yeah, down here, custom field choices. So there's a broadcast, non-broadcast, point to multi-point, and point to point. Okay, fantastic. So it's, type things correctly. It's really easy to add stuff this way. And it's you can do a whole bunch of this stuff. It takes a few minutes. As you can see, this video has gotten very long, but we spend a couple of hours building the framework, and then we can come back and just do this over and over and over again and have everything stood back to like a clean slate from a lab topology standpoint in a few minutes. So that's the benefit here, right? This is about repeatability and an easy repeatability without errors, right? Manually doing this over and over again, we're going to have errors. We just will. You can see how many errors I made in this video just typing stuff in, right? So this gives us the ability to just get rid of those stupid errors and do the repeatable task over and over and over again without having to deal with that. So now that we have this added, I'd like to just show you what that might look like. Let's add one with the GUI real quick. We wanted to do OSPF area grouping. We'll put that in OSPF. That's the key. This one's going to be a selection, description, OSPF network, type. Okay, put this under interface. I wanted to do this to show you what it looks like in the GUI, and then, you know, what it would look like in the GUI when you're under the interface. Grab our values real quick. We want to do point-to-point, broadcast, non-broadcast. So this is what it looks like doing it manually, as opposed to using Ansible. Great. All right, let's take a look at a device. So let's look at, we'll look at this one here. Under interfaces. Okay, so under the interface, in here, we have our standards available fields. If you click on this configure table, you can actually change what's available in that table by default, and it'll track with your login. So if you make a change here, it'll be there every time you log in. So the way you want to do this is, you can see all these are highlighted. You want to hold Control or Command if you're on a Mac and highlight the next one. That way it doesn't remove the columns that you do already have selected, in case you want to keep those the same way. And then what you can do is you can move these up or down, which will change the order left to right. Okay, so click Save. Now, if you'll notice on the table, we now have a network, an OSPF network type field available. And if we were to edit this from the GUI, we would also have a custom field section available here. Now, this wasn't here before. It has a drop down, and we can select what type of OSPF network type it should be from an interface standpoint, right? Maybe we want that to be point-to-point. Click Update. And now we have point-to-point in there. So as we progress through the workshop, the next piece of the puzzle is going to be pulling or querying the data out. And so we want to get it formatted in here, so when we pull it out, it's easy to dump into a Jinja template that's going to create a configuration file that we can upload to the router and provision all of the things immediately. So anyway, that is a super long introduction to managing Nautobot with Ansible. You saw the list of modules that we have available. You can manage pretty much every single table in here. You can add, delete, update. All of that data can all be done via Ansible, which is great for including that in your workflow. So an example could be, well, we have a new router deployed, or we're going to deploy a new router. We can use Ansible playbooks to pull that data out of Nautobot. Let's say we put it in a planned status. So if you look at the device tab here, we can change the status, right? So maybe we have a whole site that's in a planned status. We've built it out into Nautobot so we can track our inventory. We know it's going to a specific location. We can track all that stuff, and as things show up, we can change statuses here to kind of reflect where it is in the process potentially. But we can also use that status to control our automation. So if we have a new office that we're standing up that's got a switch and a router, a few other things, we can use Nautobot with an Ansible playbook to actually check to see if it's available. We can connect to the management interface, then we can push the configuration to it, all based on a Jinja template. So now we've got extensibility sorted. Let's move on to the next role that sorry, not the next role, but the next task in our load Nautobot role. Want to do is go back to the Nautobot data directory over here where we're storing the data we want to place into Nautobot. So under here, we want to create a new file. We'll call this ipamdata.yaml. And in here, we basically just want to insert the namespaces, the VRFs, however we want to track the VRFs and the prefixes under those VRFs. We want to just provide that information here in this text file. So if we're looking at this text file, under Nautobot, we have the option to assign namespaces, and then we can assign prefixes and VLANs and different things like that under a namespace. I believe that's going to be more useful for virtualization like Kubernetes. That way you can track how you're assigning IP addresses to, let's say, a Kubernetes cluster, for example. So we'll go ahead and just add this in here. Maybe we'll use it later. The VRFs, we're going to use this to track our lab external management that we're going to turn up in the container lab itself. We'll assign an RD. This is required when you create a VRF, and then I believe a namespace is also required when you create a VRF. So we'll include this namespace up here and this namespace inside the VRF as we create it under the VRF section. And then here's, of course, the list of prefixes that we're going to use in the topology. And if you go back over the topology, you'll probably recognize those. So the IPAM module in Nautobot, you assign an IP address under a prefix that you create. So you should have a prefix and then an IP address. So then here's all of the IP addresses. Okay. And then you'll notice here we'll assign a namespace to the prefixes we're going to use in our external management as well. Okay, so let's save that, move this aside, and close some of these. Now again, we can go back to the Ansible collection, look at the network, you can check the plugins, look at the modules. We need to find the module that adds namespaces. These are all in alphabetical order, and I believe we got to find it in the ends. Here it is, namespace. So we pop that open, you can see an example again of how to organize that playbook. So under here, we'll just take and copy this. And we'll change this over to our play, our task. So we're going to change the tag. Let's call this IPAM. Actually, you know what? Almost forgot. Let me undo that. Well, let's just finish this. We'll call this IPAM. We need to do something before this, and I just totally forgot. We'll call this task IPAM, and then we'll just say build Nautobot IPAM data. Before we do this, we need to do one other thing. We need to build in the Nautobot organizational data. So we'll import that. I think what we'll call this is organizational. This, we'll use the same name. Call this organization. So while we're at it, let's create another file. Under here, tasks, file, organizational YAML, And then we might as well do IPAM as well. Okay. All right, so those are in there. Let's move this over, keep it organized. And then let's look at organizational data. So there are a few things that need to go into Nautobot before we create other things. I believe I mentioned that before. Let's create a file. Call this organizational data. Oops. It's a YAML file. Okay. Inside of this, we're going to place, we're going to assign, every device needs to be assigned a physical location. That would include like IPAM stuff. VLANs would be assigned to a physical location typically. To do location though, we need to set up location types. So we'll start with that first. That would be the first order. So when you create a location in Nautobot, it must be assigned a location type, which means you have to create the location type first. Now, what the location type allows you to do is to assign specific tables in the Nautobot database to that type. So you could organize, now I just did home lab and just basically put everything I would need under there, but you could potentially organize your locations, your location types by a specific content type or set of content types that you want to use. A little more robust than, say, putting everything under the same location and then, I don't know, using tags to organize it or something like that would be another option. So what they did here is they just went with location type. I think better organizationally, I think it probably works better in the long run. Okay, so we have our location types. We're going to assign all of our location to the same location type. Our location is going to be the Nautobot Workshop. We'll do the East Side Data Center, the West Side Data Center, the backbone. Okay, so we'll have those locations placed in. The next thing we'll want to do is create what is called a role. A role is another way to organize all of your data. So specifically devices and virtual machines can be assigned a role, as well as many other things, including prefixes and addresses and such. So those can all be assigned a role. So when we create the role, again, we have to assign a content type to it. You can even have relay racks in a specific role. So it's just, again, another way to organize the data in Nautobot. For our use case, we will just assign roles to routers, because what we want to do is use those roles for our routers to assign specific Jinja templates. So if they're in a specific role, they're going to have a slightly different Jinja template potentially, right? Like a customer edge router is not going to support MPLS, for example. So we won't include that in the customer router configuration template. Same for the data center potentially, right? The data center leaf will primarily be external PGP. And so we don't need to run MPLS there, and we don't even need to run OSPF. So we wouldn't include OSPF as well in that template, okay? And then this management switch, we're going to place this in here, even though we're not technically don't have a management switch. We're going to use this so that we can track and provision the external management in our Containerlab topology. Okay, so we'll just create a device name for it, and then we can use that as we pull data out. Okay, so organizational data, we'll save that. In the organizational YAML that we're going to reference here, we can look up, again, the example tasks that you will have under the Ansible collection under under the Nautobot folder. Basically, we need 3 tasks to go in here. We want to create the location type, we want to create the locations, and we want to create the roles. Now, most of this stuff is going to look very similar. All we're really doing is changing the module that we're using in each one of these. For the most part, I mean, you're going to change the key values that go into it, but a lot of them are very similar. So there's definitely a lot of copy paste that can be done here. Certainly can copy paste from the examples provided for you in the Ansible collection network to code Nautobot folder as well. And again, all of this is available on the Git repo, but I didn't want to end the video. I know it's a long one, but I didn't want to end the video without at least walking through why the data is laid out the way it is. So organizational data over here, we have that laid out. Let's place in our IPAM tasks. And again, it's going to look very similar. From the top, of course, we have to create the namespace before we can assign anything to it. Same goes for the VRF. We have to create that before we can assign a VRF to a namespace, and then we can create the prefix. And so what I'm using here is the omit, the default omit. In case I don't have a namespace in the data over here, then I just want to omit this field from being filled out so it doesn't create an error when it doesn't exist on the data we're inputting. And then at the very last task, I'm assigning a loopback role to the loopback IPs. And so I had mentioned before, you can add roles or create additional roles beyond what already exists in Nautobot to IP addresses. This is one of those roles that exist. So if you were to go into Nautobot and look up, after you assign all this, you can see these specific, you could actually filter on this role and get all the loopbacks, for example. So I'm just gonna apply that role. I don't have a use for it yet, but since it's available, I'll just go ahead and use it. Okay. Okay, I think I was misspelling something. There we go. All right, so we'll go through, create the location types, the locations, the roles, all the IP addresses, the prefixes, and VRFs and all that stuff. Okay, and what we'll do is while that's running, let's switch back to the Nautobot application, and we can see what it looks like when stuff is being created on that end. Okay, so in the Nautobot application, we have a change log over here on the right. So we can see quite a few changes have been made, a lot of IP addresses. It's working on IPv6 now. And if we go under organization, we can look at the location types that we created. Here is the home lab single location type with all of the assigned content types here. And then if we look at the locations, here again are the locations that we created. So what I had done here is the Nautobot Workshop is the parent location, and then all of these other locations are actually nested below the Nautobot Workshop. So you can organize your locations in this fashion. When you create a location, let me just hit edit on here. There is an option to make it nestable, I believe, somewhere. Is that here or somewhere else? That may have been a content type. Well, anyway, you can, so what you can do is you can actually nest locations under a location, let's say group name or something like that. So all of these would be under the Nautobot Workshop location. We edit one of these. Yeah, parent. So you can select a parent here, and so that will nest them in from an organizational standpoint. You can organize the locations in that way. Okay, what was the other thing we had done outside of organization? Roles. So down here, and this is all under the organization menu. We're on the left. So under roles, we created a few. We created the provider edge router, route reflector, the main router, management switch. So those are all here with their appropriate content types assigned to them as well. And we'll, again, these things we created here, we'll save and use. We'll assign those to the devices that we are creating for the lab topology. And then in here, we had talked about the loopback. So this loopback already exists, and you can see it's set to the IP address content type only. So that's the only place it can be assigned at this point. And you can edit these. So if there was a role maybe that you wanted to use outside of the content type it's already assigned to, I don't know, like billing, you can edit these and you can add additional content types to them to be used in those tables. Okay, so the next thing was IPAM. So down here on the left, IPAM, we have our VLAN organization here, names, VRFs, all under the VRF organization, prefixes, IP address, and then of course IP address assignment. So we have to create an IP address before we can assign it to an interface, which is why we're doing the IP addresses now. So if we look at the namespace, we can see our two namespaces. So one comes already created in Nautobot, and that's global. And then of course, the one we generated. And then our VRF right here is the one we created. Let's click on it. So you can assign import and export targets on these VRFs, which can be used if you're going to manage a VRF. Well, we can do it from in here. And then we can pull that data out with a GraphQL query of some kind. And we can look at that as well. But that's kind of a nice option to have that available. Typically, your import export targets on a Cisco router would go in the VRF config, which would be, not quite under an interface, right? We assign an interface to VRF, but import export targets are assigned at the VRF config from the global config line. And we can assign prefixes to it and whatnot as well. And that's all tracked under here, as well as assign devices to the VRF. So you can what's nice is the GUI kind of pulls that stuff together. You can get a quick idea what's where when you're going through the GUI. And then we did prefixes. So here's all the prefixes that are being created here. Now, what's cool at the prefixes from the IPAM standpoint is you can see as we assign IP addresses, or create IP addresses, I should say, not assign them, but create them, we can see the utilization count out of the 254 available on all the prefixes I created for IPv4. So if we were to say, click into one of these, we have all of the child or associated IP addresses here as well. So 100.0.254 is actually what we're using for loopbacks. And if we click on there, we should have 10 of those generated. You can see that here. And then what's nice is it will show you what IP addresses are available in between the ones you haven't used. The other thing you can do is if you need to, let's say, add a prefix that isn't active, well, you can pick that status here. So they have deprecated, reserved, and active available. Now, what's nice with the statuses is you can actually add statuses. So if one that you would like to use doesn't already exist under organization, you can add those. So there's under metadata, that's where roles exist, tags, and statuses. You can actually create additional statuses. So I don't know, if there was some other status you wanted, let's say there's something you put in a maintenance mode or something like that, and that doesn't already exist. Well, you can create that, and you can see maintenance does exist, but it only includes interfaces and VM interfaces. So if there was some other component that needed to go into a maintenance, you could add that content type here and then use that status for that object. Then we'll just take a look at the IP addresses too while we're in it. Okay, so here's all the IP addresses. And you can see the ones we've assigned with the loopback role. Okay, now all of these are unassigned at this point. You have big red X here. It says, nope, it's not assigned. So that will change as soon as we start assigning this to devices. But to do that, we first need to create those devices. So let's go back to VS Code and we'll do that. Okay, so the playbook is completed. So we have all of the prefixes, IP addresses now created. So the next piece of our data that we need to import or create is the the devices. So we will create a new file under the Nautobot data folder here. Call this Nautobot devices.yaml. Close that up, and we'll get rid of these two. We'll need to obviously include that here, so let's do that now before we forget. Or more precisely, I forget. Devices. Okay. So over here, when we're creating devices, physical devices inside of Nautobot, we need to first create a couple of things before we can add those devices, because they have to be assigned to those things. So from the top, we have to create a manufacturer. Typically that's going to be, Arista, Cisco, Juniper, something like that. What we are doing is creating 3 manufacturers. One of those is going to be Docker. We're creating that for a specific purpose, and I'll show you that. But essentially, I want to track in Nautobot the management switch, essentially, that we're going to virtually create for the topology. Once those are created, then we'll want to create a device type which has to be associated to a manufacturer. So we'll create the CEOS model, assign that to Arista, the IOL model, and assign that to Cisco, and then of course the network model, and we'll assign that to Docker. We'll give it a U height of 1. Even though these don't really exist, we'll just assign it a U height. I believe the U height is a required field that needs to be filled out, so we'll fill it out. The other thing, the U height here, so this is a DSIM tool. I haven't really gotten into that because it's not something I think is necessary for virtualized topology, but all of these devices, these device types, it dictates how much rack space it's going to take up, and it in Nautobot actually models the relay rack and how much space is left versus what's available, contiguous, non-contiguous, and all of that good data center inventory management stuff that you get. So that is available. You certainly can use it. It's very helpful. The next piece we're going to need to track is the platform. So the platform typically is, as you can see from an Arista standpoint, the name of the platform. So typically Arista is EOS is how they refer to it. Cisco refers to it as iOS, and there's 2 variants of Cisco operating systems now. You have iOS, well, 3 variants, I guess, but iOS, iOS XE, and iOS XR. There's, I believe, from a platform standpoint, iOS works for both iOS and iOS XE. I don't think you have to make a distinction there. The other role platforms play is identifying it when you use it as a dynamic inventory for Ansible. So when you pull a device like this out, we can grab the network driver, or however we name the platform. We can use that to tell Ansible what kind of network device it's interacting with, among other things. Like same thing works with Nornir as well, or something like that. You can use that network driver for those purposes, so that the correct modules are being used in the background potentially, right? So it can communicate, and you can do some validation stuff as well as pulling information off the device and how it interacts with it or should interact with it. The main differences between, say, Arista and iOS or Cisco is, like, Arista has an API that runs on the switches that can be utilized. And so if you were to use Arista modules through Ansible, it will utilize that API rather than just using a Paramiko or something like that to communicate via SSH. So you have that option. And that's what the network drivers help dictate. Okay, the other thing we want to track is software version. The reason why we want to track this for a virtual device, not that it matters, but when we are building the topology, the way you reference your Docker image that you create with Containerlab is pretty much based on the version that you're using. So the tag essentially is going to be the version in our case. And so I want to track that here so that I can properly create the Containerlab topology with the data out of Nautobot and use that to do it. All right, next piece is, of course, defining all the devices. So there's a few important things here, obviously, like the name, the role it's assigned to, location it's going to be assigned to, the device type, platforms, all the stuff we just went over. We are going to assign each device to one of those. The software version, IP address, so primary IPv4 and primary IPv6. Those are typically the reason why those are important and why you want to make sure you assign the right one in Nautobot is typically you would use that for your management IP. So if I want to communicate with the device and I'm pulling data out as a dynamic inventory, that primary IPv4, IPv6 will be set as the Ansible host automatically, unless you tell it differently. But so what I typically do is I assign primary IP4 or IP6 to the address I want to communicate with the device on with the dynamic inventory from an Ansible standpoint. So we'll assign it some BGP attributes and peers here, which we'll use later. And then, of course, the interfaces. We'll want to basically what we're tracking here is the interface, what it's directly connected to. So another nice option here is we can attach interfaces on physical devices to other interfaces on other physical devices, so you can map connectivity. What's nice with something like this and why you'd want to track it is inside of a data center, if you are going from relay rack 1 to relay rack 10 in a different row, well, there's probably going to be a patch panel involved. And so what you want to do is physically track the connection from that device to that patch panel, front and back port of the patch panel to the other patch panel, or series of patch panels to get you to the other relay rack in a separate row. Out of that patch panel into the next device. So what that gives you the ability to do from a Nautobot standpoint is actually trace the patch all the way through from device A to device B, for example. Or if there's optical gear in between all of this stuff, well, you can track connectivity from device router A, we'll call it, to router Z, including all of your patch panels and various optical gear in between. Right? So I typically track that stuff as part of my source of truth. I want to know where it's connected. Another benefit to this is I can tell the person who's working inside the data center what should be connected to the device, and if they were to trace it out, what the other side should be. And we can even use, of course, with routers. You can use LLDP or CDP, if you still use that, to validate that it's actually connected correctly. And if it's not, well, then maybe we don't move any further until that's fixed. Stuff like that. All right, so interfaces are all defined for every device. I think we have 18 devices, something like that. So that'll all be in here. And I've laid it out in this fashion. So basically, interfaces is another list of key value pairs nested below the name of the device. And so we'll have to iterate and loop. We'll have to iterate, I guess is a better term. We'll have to iterate through all of these to add it into Nautobot one at a time. So can't create an interface without a device. You can't create a device without some kind of manufacturer device type. So we'll have to create this stuff in the correct order and then assign it as we create. And then down here, Ethernet 0, the reason why we were tracking, actually no. So we'll have Ethernet 0, we're gonna track that in here. We're gonna assign that one to a VRF, the CLab management VRF, because that's the VRF that will be generated in our boot up configurations for the topology. So that'll be in here as well. Okay. So you kind of get the idea, right? This is all just all the same stuff. One other thing you'll notice, of course, is
OSPF stuff I forgot to mention. So, and MPLS. So the custom fields we created, we're going to use a couple of those here as well. So as we create the interface, we're also going to assign the correct value to the custom field we created in the prior task. Okay. And I think that's like that's the 50,000 foot view on the data we're using. Next piece is going to be, of course, now we got to create a whole bunch of tasks for that. And to do that, we're going to need another import task here. We're going to tag it with devices, and we're going to create another task file name called devices.yaml. Go along with that, save this. Okay, so like we talked about, first things first, manufacturer and device types. And then we'll just go down the list, basically following this order, pretty much. After device types, we can create platforms. After platforms, we can create the software version. After the software version, we can create our devices, because now we have everything that we need under the device. We have everything created that we want to assign the device to, or assign to the device. So in here, in this create device, we're going to assign it a device type, a role, a location, a platform. And then of course the platform will track the software version. That makes sense. So there you go. But we'll do this. I think what we'll do is we'll assign the software version later here after we get the device created. And that's going to be a little more complicated. So why don't we go ahead and add this stuff here. I'm going to go in order. See if this works. So we'll remove those tags, devices. We'll let this run. All right, while that's running, let's take a look at the application. Okay, so in the Nautobot application, see again over here in the changelog, looks like those devices were created, the software versions, the platforms, device types, all that good stuff. From devices, we can take a look at all of that. So we have under device types, the manufacturers here, so we can see those have been created. We click on one of those, we can see all the devices that are assigned to that manufacturer. Same for device types as well. IOL, we can click on that. And I believe we can see other things that are assigned to this device type. So one thing you can do with device type, I haven't done it here because I don't think we need it, but let's just say you're tracking a Cisco 38, I think a 3850, 3650, something like that, right? Those typically are uniform, and they'll have a specific port count depending on the model that you buy. And so what you can do is actually, you can create devices that go with, interfaces that go with that device type, along with power ports, power outlets, that kind of stuff. So in that case of a 3650, for example, well, we can just already have the 48 ports on a 48 port 3650 switch, right, already created. So whenever you add the device type, well, you don't have to go back and create the interfaces separately. It'll already be there as you use the device type. So that's pretty handy. And then maybe what you could leave up to a variable is how the last four ports are populated based on whether or not you actually added a 10 gig port over there, or 40 gig port, or the module, right? And so you can actually include those module bays too, frankly. And then you can populate those module bays with whatever module you purchased to put in the right side of the switch, for example. So all of that can be created as soon as you create the device type. So that's pretty handy. Just avoids having to do that kind of work. It's already available. It's nice. So that is an option available. Platforms. So you can see our platforms here. How many devices are assigned to those? If we click in it, I think it shows us. Yes, it does. There you go. Okay. And then the network driver mappings. So what I was talking about before is when you pick the network driver, it provides specific things, specific mappings to those network drivers. And you can see those here on the right. So under Ansible, the network driver mapping would be Cisco iOS. I believe if you look at the modules on Cisco module, that's what it'll look like. And then you can see like Napalm, NetMiko, PyATS. Okay, all of those network drivers can be picked up. All of those network driver mappings can be picked up out of here when you use when you pull the information out of Nautobot, and those things will get mapped in that fashion. Software version here. This is assigned to a platform. Okay, so there you go. And then under devices, you can see all of our devices. Okay, and then their locations, type that we provided. And then as soon as we start assigning primary IP addresses, those will show up over here. And then you can configure these tables as well. So if there's something missing you want to see in there, well, you can just highlight it and add it in there. So IPv4 and IPv6 rather than just IP. You could show those. You could show the software version, all that kind of stuff. Tags. Again, we just save it and it will update the table. So now we have, rather than just IP address, we have IPv4 and IPv6. Now this corresponds, I believe, to the primary IP, and you can assign both. So that's available. Software version would be available then in this table as well, once we assign it. Okay. All right, let's go back to VS Code. We got a lot more to do. So back in VS Code, under Create Devices, we want to go ahead and add a few more things. So assigning the software ID pairs. I had a little bit of a problem here trying to get this done through the module. So what I had to do is create a Ansible task that first builds a list of device to software version ID pairs. So what we do here is we're just doing a simple set fact, and we're going to pull the software assignment out of Nautobot and create a list here that we can then use to update using the API each device. Okay. Couldn't do it with the module. I don't know why, but I believe I have to look into the code in there, but I think it just wasn't allowing me to use the name. Needed to use the ID, so I had to come up with a way to look up the ID, and of course that wasn't working either. So the nice thing here is if something doesn't work with the Ansible module that comes with it, we can file a bug. That'd be the first thing to do, and then we got to figure out a way around it so we can get it fixed. Or we can fix it ourselves. If you know in here, what's kind of cool actually, is if you know exactly which piece of the code in here needs to be fixed, you can just fix it. And then you can file basically a bug and just tell them exactly how you fixed it, and then they can tell you good or bad, and then they can include that in the next update. Outside of that though, sometimes what I do is just come up with another way to do what I thought I could do with the module and couldn't. So we'll build a list of device software, and then we'll update it with the API. Pretty much that simple. It's not a whole lot to it. And I think what we need to go back and do is, the way we'll do this, we'll have to register the device ID so that we can pull that along with the software version ID, which both of those things were registered here and there. So what we'll do is we'll actually go back and we'll let this whole thing run, which will give us, I believe will give us the Nautobot ID for each one of these objects when it's created. So let us do that now. And we'll see if it gives us ID, but I believe it will, even though it's not, everything is going to be in green. It's not going to actually change anything, but there is a lookup that's performed to validate, and so we should get a Nautobot ID out of that. So we'll just sit patiently, let this thing run. And I'll probably speed it up. Okay, let's see if this works. All right, so we have software ID in the register. We have the device ID in the register when it went through and created the software version and the device. So those IDs were captured in the register, and then what we're doing is creating a list of both of those things together. So this device ID goes with this software ID. And then we will take that list and we'll iterate over it and put it into Nautobot. So that should be done now. I think that's what this was doing. Update device. Okay. Now let's go back to the application and see if that worked. All right, so back here on our device list, we click on one of these guys. Should have software version assigned, and that looks like the right one. We go to software version here. There you go. There's your devices assigned as well. And if we click on those, we've got a little widget over here, stats widget, where we can track some things, including what it's assigned to. Okay, cool. One nice thing here is you can actually track software image files in here. So application, well, if we were to click on this, try that. Pick a software version, right? We can provide the image name that's supposed to go with that, and whether or not it is an active one, an end of life one, or extended support, that kind of crap. And you can include all this stuff, file size, and then a URL. So what's nice about this is you can use Nautobot to go fetch this file from an Ansible playbook. So if there were, say, a bunch of router switch upgrades that needed to be performed, well, depending on the software version we were upgrading to, we could also attach the correct name of the file, where to go fetch that file from, the image size, the checksum, so all of that could be validated before downloading it and applying it to the switcher router or something like that. So very handy for people with a lot of switches. You got to do those upgrades sometimes, and they can be very painful because we typically don't automate them. They're kind of scary to automate, but we can inch in that direction, and we can, maybe do more than just one per night, kind of a thing, right? Because we got to keep an eye on that stuff. And this is the type of stuff that something like Cisco DNAC is fixing for you. It's taking care of those software upgrades. It's validating them. It's doing all that annoying stuff, right? Those little annoying tasks. You can do that without buying that software. You could do that yourself. You just got to build it. And so this is where, again, source of truth is invaluable because there's a lot of stuff we need to track about these devices, and we need one place to go to get it that we know is accurate. And so that's where Nautobot comes into play in our automation. Okay, let's go back to building more tasks. All right, so back in VS Code, I'll go ahead and get everything else for our device created. So next part that we can do is the interfaces. Once the interfaces are generated, we can actually assign or add the addresses, those IP addresses to those interfaces. So here we'll create each interface on the device as defined here. We'll use the sub elements again to iterate through this list here of interface names and stuff. And then once that interface is created, then we'll go back through using the same sub elements for interface and grabbing the IPv4 and then the IPv6 address and assigning that to the interface. Once that is completed and you have an address assigned to an interface of a device, well, then you can actually make that interface or that IP address that you've assigned to a specific interface the primary for the device. And so we only have IPv4, and so we'll only assign an IPv4 address. After that, we can move on to creating our connections. And so guess what? We can manage that also from Ansible, which is nice because if you can, there's a lot of ways to skin a cat here on how to do the connections, but you could potentially go out and brownfield some of that as well. Just go discover how things are connected and then put it into Nautobot. If it's wrong, that's obviously not going to be the best way to do it. The other benefit to tracking what a device is connected to is you can actually use that for your descriptions, so that you actually so that you can come up with maybe accurate descriptions, more accurate descriptions than maybe what you have. And so down the road, what that looks like after everything stood up and running in a production environment, well, if somebody decides to move a cable, we could build automation to help them move, interface Gigi 101 to, let's say, 105 for testing purposes or something like that. Well, we can just move the whole config. And then the description would move with that, and we don't forget about it. And if we do that, then we can update the cable's connectivity in Nautobot as well. So we avoid configuration drift on an interface description that way, or potentially we could avoid that. Big organizations with lots of interfaces, and if your interfaces are dead on, you're doing something right, but generally they are not typically that way. So you need a way to track it, and you need a way to do some validation on it. So here you go. One way to do it. Okay, so I think that's everything we want to add for devices. So what did we do? We assigned an IPv4, we tracked our cable connections, and then we updated the interface for each device with a custom field attribute at the very end. Okay. One thing you'll probably notice in this data is I am because Ansible goes in order from top to bottom. We're going to assign the interfaces that way too. So it's going to start with the very first router, which I believe is P1. And it's going to use the Z side of the interface to make those cable attachments. Now I've tracked them both A to Z and then Z to A. So it's going to go back through and it's going to recognize that those interfaces are already connected and it won't generate new connections. So that's nice. Okay. So one thing I am going to do, just to speed this up, is I'm just going to comment out all this other stuff we've already done. Okay, and then we'll run the playbook and it'll just start in at the create the interfaces section for now. This is gonna take a couple minutes. So we'll jump back on when this is done. We'll take a look at the application and take a look at all the things we've added. Okay, so the playbook finally finished. As you can see down here in the total seconds run, it took quite a while. So yeah, one thing you'll learn about Ansible, it's not fast. So just keep that in mind. There are ways to speed it up, but if you just run it without any tricks, it's not fast. So it looked like 1300 seconds is how long it took to add all of that stuff from the Nautobot _ devices data input that we were using. So all of this has been added. So let's jump over to the application and take a look. The next thing we're gonna do after we look at the application is I wanna go in, we need to add our BGP tracking stuff that we wanna do that way. We're gonna manage that from Nautobot as well using the BGP plugin. So let's switch over to the application. So if we click on one of these devices, let's click on P1 and we take a look at the interfaces. We can now see all of these highlighted green shows that there is a connection being tracked. You can tell that over here by this cable that can be removed. These little trace buttons, as I mentioned before previous in the video, you can actually trace out all of your connections in a nice little north-south diagram, which is pretty cool. I like this feature. I think it's great for data centers, particularly where you're going through a lot of patch panels or other intermediate devices. Pretty handy to have that. So everything looks good there. So what we're going to do next is under this routing thing, I don't know what you'd call this thing. Anyway, this routing thing here, we have BGP tracking. So we can create an autonomous system or set of systems depending on how many we're going to use. You can set up system ranges like with Cisco. Actually, not with Cisco. I don't think that's how that works. Anyway, you have a lot of options here. Peering group templates, this kind of stuff. It's very Cisco-y, but Juniper has something similar. So all of that can be cross-functional. It just depends on how you're going to set your template up and use the data that you have there. So it's more of a common nomenclature than it is a specific use case with a specific vendor. So what we're going to do is get the autonomous system set up. We're not going to use peering templates right now or system ranges. We are going to use routing instances. So every router is going to have a routing instance, at least one, right? If you were using VRFs, maybe that would be a separate routing instance, for example. We'll include address families. And then we're not going to use peer groups at this point either, but that is available and very handy when you are connecting a lot of BGP peers for a similar purpose, like settlement-free peering, or something like that. So let's switch back to VS Code and we'll take a look at how I set that data up. So in our VS Code, under each router, we did define some BGP attributes here. So if every device has the associated ASN, DAFI, SAFI that we want to include, and then the peers that we want to create along with their inbound and outbound route map names. So the way we are going to add this data in is under our Nautobot data. Actually, what we're going to do is we're going to use this information here, but we need to create another task or set of tasks. So in our main YAML, we want to put a new import task for BGP. I'm going to create that file here. And in our BGP file,
we're going to start setting up the autonomous system. We'll do this in the order you saw it in the application. We need an autonomous system to associate that we can associate with a routing instance. What we're gonna have to do after that, once we get these two, is notice that we're registering the output of the routing system. I need to create a new flattened list of the routing instances. And the reason for that is I'm going to take that flattened information, because I need the IDs that are generated once we create the routing instance inside Nautobot. I need the ID that Nautobot assigns to those when they are created, because we have to use the API to actually get to properly configure inside of the Nautobot plugin our neighbors, the peers and stuff like that, the address families, those type of things. So we'll create a brand new routing instance YAML, which is a flattened list of the IDs and what routers they're assigned to. We'll include that created file to use it as additional variables in the Ansible playbook or task. We'll go ahead and assign the address families to a routing instance and per router, because we'll have one routing instance per router, and then we'll have to assign address families. We'll have two of those, IPv4 and IPv6, to assign to that routing instance per device, per router. So we'll take care of that, and then what we'll do is we'll create another task that we'll do an include task on, which is where we'll employ just raw API calls. This one took a little while to figure out and to get this working, because I had to do something. I had to go and use the actual REST API rather than using the Ansible module, because I couldn't get it to work. So what I did is found a way around it. And essentially what this is going to do is it's gonna, when you do a include task like this, you can include a task and then iterate over another list of key value pairs. And so that's what this loop is here for. And so we can take that that list of key value pairs and then loop it through another task. And so that's what we're going to do on this one here. And so let me just show you how we're going to do that. Basically, we'll set all of these facts are things that we need to know to properly use the API. And the biggest thing we need is the IDs that are created inside of Nautobot, because we'll want to use those IDs to properly reference them with the REST API. So what we'll do is we'll set all of those to null, basically, blank. And then when we iterate through there, they'll already be blank, and then we can fill them back in. Something that I found out with an include task is Ansible doesn't wipe those variables out every time it loops through there, so you have to manually do it. So we'll do it this way. We'll do a lookup with GraphQL query, and that GraphQL query will stick in a vars folder in here. So let's create a new file, vars main.yaml. So inside this vars, we'll stick a query in here that's going to be used against Nautobot. Basically, what's pretty cool about the GraphQL queries, we can actually query 3 different tables simultaneously. So in this first one, we're going to look up device details. That would include the BGP routing instance that we created in the prior task. And then we're going to look up some IP address details. So this is going to be interface details like the loopback. I need to know what the loopback interface ID is, or the IP ID of that, the IP addresses ID under that loopback. Or I may also need the IP's Nautobot ID if we're using like a
an eBGP or over a point-to-point interface. I need to know what the far side of that is, and I need to know what the ID is as well. And then, of course, the autonomous system that we created in prior task, I need to know what the ID of that is as well. So all of that information is something that we need to create peers inside the Nautobot BGP plugin. The other thing that we're going to need back in here, and almost forgot, is we are doing a template here. So in this template, we need to create another file called under the templates folder. Call it safi.j2. And then this template, we'll use this template to create basically a dictionary of all of the information that we need to feed in through this task list here. All right, so once we have this lookup completed, we're going to take details out of that lookup and set facts with it. So we'll know what our peer device is based on the list that's created, or based on this list actually. So kind of go through here, we know what our peers are. So we know like this peer address and this peer address is route reflector. So we'll grab all of that information and we'll set it as a fact so we can use it as a variable. The next piece is so we'll create this little debug here. This isn't needed, but I had to use something to understand basically what I was setting facts to and just trying to keep that straight. So that'll show up down here, kind of track that a little bit. But I was running into a few issues where I wasn't lining these up correctly, and I needed something to just do some validation while I was tinkering around trying to figure out a good solution. All right, so the next piece, after we set those facts up here, is we're going to look up the eBGP source interface. And that's for the point-to-point connections. So for example, CE1 to the data center router, or PE1 to the customer edge router, that kind of stuff. We want to be able to look up those and figure out what the IP address IDs are in Nautobot so that we can properly provision this in Nautobot's BGP plugin. If that's not applicable, we want to fall back to just looking up the loopback 0 address, because that's the other interface that we'll use for peering in this lab. And then the next piece is if we can't find any of those things, and what we want to do is just completely fail the task. So it stops. And then we know we've got an issue with the data, or the data we're feeding in is missing something, or it's not matched up, something like that. I have some additional debugs in here. This, again, was here to just keep stuff straight while I was figuring out why some things weren't working, as I was mulling through a solution on how to correctly do this all through Ansible. So the next piece is we need to set some additional set facts after we get this, after we figure out what our remote and local IP addresses are. We need to figure out what our local ASN ID is inside of Nautobot. We need to figure out what the active status ID is as well, so we got to look that up. Additional debugging again, so we can keep things straight in case it fails. We want to know why and where exactly in this list over here on the right it failed in. After we have all this information, well, then we can start creating the peering between the endpoints. And so those are all going to be posts using the URI module that comes with Ansible. So we'll create the way you create things in the plugin is you create a peering
which you attach endpoints to. It's a little weird. You don't see it that way in the GUI, but when you're using the API backend, you've got to do it this way. So you have to have a peering first, and then you attach an A and a Z or an A and a B endpoint to it, kind of like a circuit. A little bit. It's very similar to that. Once we have the peering established, A to B, we then can assign a address family to the A side, and then we assign an address family to the B side. So we'll do that here. All right, so we create, let me just go back up here. So we create the peering, we attach the A side endpoint and its address family, and we attach the Z side or B side, however you want to reference it, and then we attach the address family for that side as well. We'll take a look at it in the application, it kind of makes sense, but when we pull this data out, it's going to be in a nice JSON format that's readable, that we can iterate over, and it's much easier than creating this stuff manually constantly. So, you can basically use this as a template to add additional peers in later on somehow. You don't necessarily have to do it with a YAML file input. You certainly could do it by pulling it from other sources, but this at least gives you a sort of an example on how to do it and get it in correctly. So, okay, so I believe that is everything for getting the peers in. All right, so let's back to the main. And what we want to do, let's test this out, see if I've missed anything. We're going to use just the BGP tag because we just want to do BGP. And we'll let that run. This probably will take a few minutes. So we'll come back and see if everything worked. Okay, so that task or set of tasks finally finished up. Let's just take, again, another look at what we've done. And there was something I skipped over, and I feel like I need a little bit more explanation on what we were doing. But up here, we created the ASN numbers that we're going to use for all of the routers that we're going to manage. We then created a routing instance for each one of those routers. We flattened that list out. And what do we mean by this? Well, I created this new YAML file called routing instance, and I have that over here. I basically took this information from the devices here, and I basically reformatted it under this BGP. I nested it below BGP. So we have a device name, and then we have the ID. I believe that's for the routing instance. That wasn't named very clearly, but that's what that's for. And then we had what kind of address families we wanted to provision below that. And then I listed all of the peers. And basically, part of the Jinja template to get this information is it includes a lookup, and then it includes a lookup of the data that we have to grab not only we know what the local ASN is, but what's the remote ASN. So I'm putting that here in a list that's easy to grab everything from. And then of course the in and out route map information and what AFI that should go under. So essentially building the peering information that we want to generate a config for. So I'm kind of flattening that out into an easier list to iterate over in a separate file that I then re-include as a variable. So all of these vars would now be new vars under this nested under BGP. And we use those new vars in this loop here, and we do a sub element of affy-saffy, which would be this list. So there's more stuff we could include here potentially. If we wanted to input it in there, we just stick it under there. Like a good example could be maybe we want like more of a BGP global config for
redistributing connected routes or OSPF routes or something like that, you could potentially stick that in here below IPv4 unicast address family or something like that, where it would appear in your global BGP config, potentially in like Cisco, for example. So it wouldn't be a neighbor configuration, it would be a BGP configuration. So that's, the hierarchy that I maintained in the data that we're using to input.
So in our application, if we go to routing, you can see our autonomous systems have been created. Our routing instances also have been created, 2 per router. So we have IPv4 and IPv6. Actually, I take that back. I'm incorrect. No, it's one per router. We have 2 address families per routing instance. So if we take a look at the address families, here you go. So you have an IPv4 and IPv6 unicast address family. And then our peering. So here's all the peering. So basically, the way this will show up is one side to the other. So if we were to click on this, and you can see there's 2 endpoints in here, and then we'll have one for each address family. So IPv4 and then IPv6. So over here, if we just click on this, this is how it'll show up. So it kind of looks like a circuit or a connection type of thing. If you were to look at eSIM here, and we looked at cables. I think if we clicked on one of these, you see how this looks here. So kind of, I believe they use this template more or less for peering. So you have a A and B side. Let me go back to routing. We look at one of those peering setups. You have this A side, Z side. It's kind of like termination A and B. There you go, A side, Z side. You can click details on here, and it will take you under the endpoints, peer endpoints, and where you have your one side. So this is the request or the route reflector side, source IP, source interface. This information, the attributes. The address family for this, and then the other side of the peer, or rather, the peer side information. If we look at address families, we can click on one of these. It'll tell you which device it's configured towards or on. And then the associated routing instance, and then our policies over here. So if you were to edit this in the GUI, this is the information that you would have available. Now, the extra attributes are there so that you can include additional stuff from a peer standpoint, right? So the way I look at this is a IPv6. So under a Cisco configuration, there would be an address family, IPv6 unicast, and then we would configure neighbors under there. And one of the neighbor features we could put in these extra attributes would be next hop stealth, stuff like that. So among other things, but any of the neighbor specific configurations under BGP, you can use this extra attributes to configure there. Okay, so this has been quite a few things just to get this set up, but everything should be now configured in Nautobot, and then we can create the queries to pull this information out. The first thing we'll do in the next video is we'll pull out just the information that we need to create the topology, and then we'll be able to use that topology to boot or turn on the virtualization environment with Containerlab, and then from there we can start generating the full router configs to get BGP, OSPF, MPLS working on the backbone.
between the peer routers and the customer edge and all that stuff. So that'll probably be pushing configs to the router is going to be like part 4. Part 3, the next video, we'll be getting Containerlab set up and running. So thank you for watching the video. Hopefully it's helpful for you to get at least some kind of framework. Click subscribe, and you'll get the updates when I release additional videos. Thanks for watching.